evening to all of you. I'm Dr. Chaitra Bharat, and I extend a very warm welcome to our panelist, Dr. Maruthi Gowda, and our participants on behalf of Phoenix Academy, Mysore. Before we start the webinar today, let me put out a few instructions for all of you. So all participants, please keep your audio and video off at all times. You can use the chat box for whatever queries you have. You can post your questions for the speaker in the chat box itself. All questions will be taken once the speaker finishes his presentation. So it will be at the end. The link to download your certificate will be provided in the chat box at the end of the webinar. So please adhere to these questions. So what are we waiting for? So I'd like to introduce our guest to you before we start. Professor Gowda is a plant virologist and vector entomologist by training, working in the UK for the past 20 years to identify sustainable solutions to some of the worst plant viral disease epidemics in Africa and Asia. He did his BSc and MSc in plant pathology at the University of Agricultural Sciences, Bangalore in India, and PhD at NRI on cassava viral diseases and their vector whiteflies. Following his PhD, he joined NRI in 2001 as a postdoctoral fellow and excelled to become the head of a research group and a professor within the same department in about 15 years. He has won several research grants and led international teams to understand the factors driving plant viral disease epidemics, especially in Africa, and using the knowledge generated to develop sustainable control measures. I welcome Dr. Gowda to this webinar, and I now hand it over to him. It's over to you, sir.
Okay, excuse me. Thank you, Chaitra, Dr. Chaitra, for introducing me. Can you see the screen, and am I audible?
Yes, sir. Perfect.
Okay. Okay. Yeah. Thank you very much, everybody, for participating in this webinar. Especially thank you, Dr. Chaitra, for this opportunity to share my basically like a lifetime's work experience on plant pests and diseases. So the title, as you see, is Studying and Working in the UK Academia, basically sharing my experiences. How do I go forward? Okay, it's the bottom button. Okay, so this is the lecture outline. I'll tell you a little bit about my early life and background and my career, and share a bit of experience while I'm studying in the UK, as well as when I started working in the UK. And we'll share some experiences on how to make it in a competitive research atmosphere, such as in the UK. And then basically kind of give you an idea about the work that I've been doing, which is my research area on plant diseases and pests. Mainly focused on Africa, but also, I mentioned that I did have some experience of working in India and Bangladesh as well. But just a bit of disclosure right at the beginning is, unfortunately, this topic is not about if someone is looking for guidance on how to join UK universities or how to get a job in the UK. Unfortunately, no, this is not about that. This is more about basically like kind of my journey, if you like. Although I'm happy to answer some of the general questions later on about how one can actually get an admission in the UK university or how one can actually look for a job. Okay, so with that brief introduction, let me move on to the main slide. So this is basically kind of where I come from a village called Midatharahalli from Madhugiri Taluk, Good district, near Bangalore. So it's very much a typical South Indian village in a very dry area, surrounded by beautiful hills and mountains. And on the right-hand side and the bottom right-hand side of the slide, you see the typical village picture. That's the picture is my daughter in the picture, kind of herding a buffalo, which is pretty much what we did as children, really. So kind of grew up on the farm and knew all the trials and tribulations as a farmer in India. And one of the reasons why do you think I'm sharing this is because basically this was the kind of inspiration for me to continue to work on plants and continue to basically doing my agriculture degree. And this is where I basically started developing very strong interest naturally as a son of a farmer. So I'm very lucky to be able to continue in the same field. So this was only kind of part of my family, not all of it. We were all kind of compound family, giant family, all kind of grew up in one roof, under one roof. So there were lots of cousins and nephews, nieces and siblings basically to grow up with. So it's one of the best moments in my life basically. So having lots of fun at the same time. So let's fast forward to my university days. As I mentioned, I joined BSc for BSc in agriculture in the GKVK, the beautiful campus you see there. So after the agriculture graduation, then I joined MSc in the Department of Plant Pathology. You see the picture of Professor Muniappa. So I did my master's under him on whiteflies and tomato leaf curl viruses, basically looking at resistance and ecology. While I was working with him, I had kind of really not planned for doing my PhD in the UK because I was managed to secure a job as a commercial tax inspector or doing my master's. So it was really not at all my plan to do a PhD or actually for that matter to travel abroad. So I think I kind of really put it to fate that it was meant to be probably doing something different than being a CTI in India. So I was offered a PhD position at NRI. NRI, by the way, stands for Natural Resources Institute. Incidentally, it's not non-residential Indians. I know NRI, that NRI is more popular with Indian friends, but this stands for Natural Resources Institute. Okay, so I was offered the PhD position. I mean, among the 10 or so students who were in the lab, I was the one selected. So probably, I feel probably I done something wrong, rather something good to be selected. And it took a lot of time for me to decide to accept this position because, as I said, I had a job and I was looking forward to settling myself in life. But after consulting many people who have traveled abroad, I thought, okay, doing a PhD would be the best thing to do. So I moved to the UK to work for my PhD with Professor John Colvin still on whiteflies and viruses, but this time is on cassava in Africa. Just kind of a couple of words about the university. University of Greenwich main campus is located where the Greenwich Meridian time, GMT, as we all know, and Greenwich Meridian line, the zero latitude line is located. It's a very famous tourist spot. Many people come there, and it's a historical spot, and you can see the buildings are also very beautiful. So it's a really great campus to kind of work. Although my campus I'm based in other campus, but I do come here regularly for meetings and other things. So just to kind of sharing, as the title said, sharing the experiences, and I do want to share, stick to that title. So initially, I think many of you probably will have known that there's a big environmental differences between UK and India. And this is the picture on the right-hand side, me on the campus where I was studying. It's snow. Basically, I arrived in February, so it's one of the coldest months. So it's a lot of snow. It's from plus 30 degrees centigrade to -5, -10 degrees centigrade. It's a big shock. Not only that, it was kind of really the dark and gloomy. It gets light about 9 o'clock in the morning, and it gets dark again by 3:30, and by 4 p.m. it's completely dark. So you hardly see sun during the winter days. It was quite shocking to the system at that time. And then I think you will know that, there's a massive cultural difference between the India and UK. So again, the reason I'm sharing is because I think some of the students are, some of you looking for moving to the UK for a job, for example, you will probably, benefit from knowing this. There's definitely a culture shock, and social changes would be huge, because from being surrounded with lots of your friends and family, and having involved in many festivals and events and occasions, you suddenly move to a place where literally you know no one, and there are none of the festivals. I mean, anytime, sometimes we don't even kind of know when there is a big festival is going on in India. Like obviously we know Ugadi and things, but some of the minor ones you wouldn't really know, because nobody celebrates the year. So there is definitely a big difference, and nobody speaks your language. The reason I'm saying all this is because, nowadays communication is not a big problem. You have WhatsApp, you have so many other social media. It's very easy to communicate to people back home. But at least when I came here, I didn't even have a telephone at home to call them. So all I needed to do was really like communicate by the letter. So I had to write a letter and wait for a month to get any reply back from my home. So it was quite slow, but it was also quite good, in the sense, everything was a little bit easy, and not very fast paced like today. There is obviously a big differences in working practices. Again, if you are coming from India to study in the UK, for example, you will notice that it's only 5 working days, but yet it's the most efficient working atmosphere. You don't need to be working till 10 p.m. in the labs, like many of us used to do. So yeah, everything closes at 5, 6 o'clock, and then you go home and get on with your other life. Okay, so if there were some of the challenges, but some of the advantages are great and flexible working conditions. You have the freedom to do what you want to do, although you have a set program of PhD, for example, but within that you will be given the opportunity by your supervisors to implement your own ideas, which is actually, I think, is a fantastic thing to do, because then you own the idea, you own the concept. I mean, they actually tell you that, this is your PhD, you go and get it. Okay, so I think that kind of probably atmosphere is different to India, where you basically, I felt at least, maybe, where you're spoon fed more back home, and obviously there are a lot of restrictions. But here, it was not like that. And of course, the facilities were great. And even as a student, I was able to travel quite a bit. So that's the kind of freedom you have. I finished my PhD in 2001. And before again finished my PhD, I was offered a postdoctoral position to continue in the same department, which was again because I kind of quit my job, CTI job back home by then. So I didn't have any particular job to go back to. So I thought, okay, let's continue here. So 1 year postdoctoral into 3 years, and 3 years into 5 years, and then basically became a permanent member of staff, and progress basically to climb all the way to the top of the ladder. But just to share some of the work experiences was, it was a little bit difficult to get rid of the student tag, because I was there as a student. It's natural, I think, probably people to assume that, although I'm kind of staff member myself. So, but I think there was a little bit of carry over from the previous year. So they were kind of still, I was still struggling to become like an independent research member myself. So that's one thing. If somebody is actually, looking for a postdoctoral position, you've done a PhD in one place, I think I would really strongly recommend you maybe go and to look for a job somewhere else. That was my kind of experience. One thing that many people probably don't know, especially not those living in the UK, is that it's an extremely competitive research atmosphere. The reason I say that is because effectively all the expenses, every kind of penny that I have to spend on the project, whether it's on student expenses, their bursary or their consumables, and including my salary expenses, has to come from the project. So that means I have to keep winning the projects. And the way it works is that the moment people stop winning the projects, basically they lose their jobs. So there is no such thing called a permanent job. It is a permanent job in inverted brackets, basically. So it's a tenure track. As long as you keep winning the projects, you have your job. Otherwise, you have probably, depending on your performance, a year or at the most a couple of years before they start looking at, okay, why you're becoming a burden to the system. So this is a one big difference between, for example, the Indian system and here, where once you have a job in India, in a university, it's a job for life. So unless, you do something really terrible, nobody will be able to get it off you. But here it's the opposite. You really have to be on your toes to be able to make your career and to keep on winning the projects, basically. So, so living in that kind of atmosphere was a little bit of tough at the beginning, like I said, because if you're a young postdoc and you really kind of trying to make in your own research field, so it gets extremely tough because on one hand your job is under threat, and on the other hand you basically have no one to support you, or you haven't accumulated enough experience or made enough friends to succeed. So that's actually important to know for those who might be looking for a postdoctoral position or even jobs. There were actually quite a few increase in number of jobs for a number of people coming to work in the UK. I used to be the only one for a long time at NRI. Now we are 5 of them, so it's not unusual. So people coming to the applying for international jobs and moving to the UK. So just something worth noting. And I was thinking what might be the reasons to succeed in an atmosphere like this is it's basically I felt keeping one step ahead of the rest. What I mean by that is it whether it's through the ideas that you're developing or through the extra efforts you are putting. I think if we do that, then we are probably more likely to succeed than fail. I also felt that you have to work hard, but not slaving. Definitely no 10 p.m. Sessions in the lab at all. So I felt, okay, you need to have a good work-life balance. So definitely work hard, make it more productive. The hours you spend, make it more productive rather than spending too many hours and ignoring your personal and family life. I also felt that to succeed, you need to have a good network of collaborators. In other words, they basically effectively become your friends in your own research area. So because trying to just develop projects by yourself or work by yourself is not going to really get you very far. So develop collaborators, make friends, and be involved in societies, other organizations, make yourself basically visible. Then building your own research area and team is really important. Basically, you're now become an independent researcher. You have your own research area and a small team of research students and postdoctoral fellows or technicians working for you. That's really key. And what I felt was there was no restrictions on what you would like to work on in the UK. That's, again, very important because later on in my presentation where I talk about, different aspects, you would realize I'm not myself restricted to plant pests and diseases. Okay, so that's kind of really important. And you have that kind of freedom here because again, one of the things probably people not aware is that there's no like a very restrictive departmental structure in the UK. I mean, for example, Department of Entomology or Pathology or Genetics and Plant Breeding, Seed Technology, all those departments that we are very familiar with in US Bangalore, or perhaps as a matter of fact in other universities, are not so divided based on this subject discipline. But instead, the departments are based on the bigger themes, much bigger themes, like crop improvement, for example. So which means you can work on pests and diseases or breeding or biotechnology or whatever the topic you can think of for crop improvement. So that kind of really sets you free to pursue the topic that you would like to pursue, rather than having complaints from a entomology colleague that, hey, you are working on entomology while we are supposed to be working on that, not you from the plant pathology kind of department, kind of thing. Okay, so publishing papers is very important. There is a saying in the scientific community that publish or perish. So if you don't publish, you really kind of perish very quickly. One thing that I also noticed was continuity on a topic and perseverance. Basically, what I mean by that is if you continue on one particular research area, then it becomes a lot easier for you to succeed rather than keep changing postdoctoral positions into different universities. So talking about research area, these are the two research or geographical kind of areas, as I mentioned, that I worked on cassava in Africa, on vegetables in India and Bangladesh. Since I made maximum impact on cassava in Africa, I'm going to focus on my work in Africa, and effectively similar work was done in India, especially on research side, but not so much on impact, especially with collaborations with Professor Muniappa, who is retired professor from plant pathology department. Okay, so for those who don't know what cassava is, this is a tropical shrubby plant. It looks like this. I think some of you might have seen it. It produces tuberous roots like this, and this is a major food crop for many millions of people around the world. Cassava is actually produced in over 100 countries. These are highlighted in green here. You can see, including in southern India. However, the maximum production occurs in Africa. About 50% of it actually is produced in Africa alone, especially for food, which is the most important point. There, cassava is both a food security crop and an income generation crop. So people actually harvest cassava, boil and eat. The cassava flour is produced from cassava roots and used in various products, like in bakery items, as well as in industrial products like cardboard making. And it's a huge source of starch. So, which is again has many uses in textile industry as well as in the pharmaceutical and various other industries. You can see here women in Nigeria peeling cassava. So this becomes an employment opportunity, a livelihood opportunity for the entire family actually. So cassava is very, very important. And I think many of you probably don't know that if you look at the top 5 staple food crops in the world, cassava is the 5th most important crop. I think this just highlights that sometimes just because we don't know about cassava, it doesn't mean it's not important. So it's really 5th most important food crop for mankind in the world. So I just wanted to put this into the global perspective to see how how important the cassava now, and especially going forward towards the end of the century. On the left-hand graph here, you see the projected population increase. We're expected to increase up to 11.5, nearly 12 billion people by 2100. And if you look at the population projection on the right-hand side, you can see the green line is actually the population in Asia, which is quite a lot already, but it's going to start declining towards the end of this century. But you see the purple line in the middle of the graph is shooting up. It's really increasing. That is the population of Africa. So they are about 1.2, 1.3 billion at the moment, and they're going to increase more than 4 billion. So they're expected to grow much faster than any other population growth seen so far, including they're surpassing the Chinese growth rate. So it's really, really a massive growth that we are going to witness in Africa, and where cassava is really grown heavily also. So you can see the very high population and a very high cassava cultivation. That means cassava is going to be really, really important going forward as a food crop. Cassava is actually called the Rambo of the food crops because among the crops you've seen there, in fact, among the 10 most important food crops to mankind, it is the one that is extremely drought tolerant. You know, climate change, we hear about it every day, how important it is, and the droughts and the longer summers, longer, you know, warmer, hotter summers are very common. And if there is one crop that benefits from climate change, it's actually cassava. So, but all the other crops suffer. So, which is actually very important going forward as a food crop. Unfortunately, you know, despite all these huge benefits of cassava growing, it also suffers from virus diseases. An epidemic of cassava brown streak disease started in about 2004 around Uganda here. You see around Lake Victoria here in these two regions, and it's really spread like wildfire very quickly, and it's actually further expanded now beyond this yellow area. And it destroyed really cassava production wherever it went. And in this area here, where it's highlighted in red, it used to be only in this area since the 1930s. But once it spread to other countries, it's really kind of went very bad, affecting the cassava production. You can see here cassava, the healthy cassava at the top, and the bottom is affected cassava roots, and obviously they are unfit for consumption or any use at all. So people actually, the way the cassava works in Africa is, as I mentioned, food security crop, which means basically the woman can harvest just one cassava plant a day and bring it home and peel it and cook it and make a meal for that day. But if it is affected by cassava brown streak disease like here, then the roots the woman bring home basically, you know, won't be edible. So either she has to go back and harvest more, and there's no guarantee that other plants are not affected, or they have to, you know, use whatever the little left over in the home or go hunger. So it's really, really that serious. And this disease is spread by whiteflies in the natural field. And if you look at the hunger map of the world, where you see most of reds and oranges are actually in Africa. So, and some of this hunger is caused by pests and disease outbreaks and droughts. And especially recently, you probably heard about fall armyworm, which has caused a major problem. It's also spread around the world. Locusts, I think, is the current problem that is ongoing, not just in India. I'm sure you've seen many videos of locusts attacking, and it's also actually occurring in Eastern Africa, really, really devastating on the crops. And in addition, if you have the double whammy of the disease, then you basically, like I said, this woman who is bringing this cassava to her home is not guaranteed that, you know, she'll be able to make a meal from it. So this is why, you know, food security is a big problem. And when you have actually in a situation like this, we have to kind of really take a holistic systems biology approach and for controlling the disease. And I tell you the reason why. Is basically like pesticides or chemical applications of insecticides are not really feasible in Africa, mainly because they're not available. When they're available, they are extremely expensive, or especially they're not profitable for a subsistence crop like cassava. If it is an economic crop like grapes or tobacco or whatever, then yes, it might be feasible. But cassava is grown for food, so they're not going to make money from it by spending a lot of money for pesticide application. So we need to look at really an entire system. So this slide is really kind of encompass the ideas from effectively 20 years of my research on this crop. So I basically worked on any aspect of the cassava crop that we thought was actually important to address. For example, starting with impact, I mentioned impact. So when the when the epidemic started, we didn't know how the disease was impacting. So we went around surveying the extent of the damage, interviewing farmers and understanding how they are coping and what kind of varieties they are actually growing, how they're getting the food and that kind of information. The very socioeconomic impact work. I'm a plant pathologist, but we can't just focus on the disease and say, okay, no, I'm not interested in doing any other work. But because they're all related work, one has to need to look at it. And as I mentioned, the atmosphere in the UK, our departments would allow such kind of work without any problem. But obviously, you bring in the experts from a different field, socioeconomic field, but it will still be part of your program, for example. Okay, so of course, we needed to work on the virus. Some of the very basic questions, like how the virus is spread in the field. What is it spreading? What is the vector? How do we detect it? What is the nature of the virus? We didn't know this. Some of these really, how do we detect it? So these are very fundamental if you are going to develop, research and solutions based on the scientific evidence. We did obviously, a lot of field studies. Breeding and agronomy was a major activities. We trying to understand, like for example, fertilizer applications. How do the plants respond? Breeding between resistant and susceptible varieties, obviously a major component to transfer the resistance into farmer-preferred varieties. The way the projects work usually is, and the reason I'm able to do such a vast amount of work or vast diversity of work is mainly because of through the collaborations. Collaborations is really the key word, because basically when we write projects, we involve partners from Africa, and they do most of the field work. Obviously, we develop the ideas and concepts and the protocols, and they implement the field work while we provide all the high-end blue sky type research, molecular research from the UK. So that meant that I really needed to travel. I mean, including, for example, impact work. You need to go and visit the farmers. So these are just some of the red lines on the maps of these countries are some of the long routes that I kind of took. They look small area because they are very long routes. Some of them like 2 weeks, 1 week, non-stop traveling for collecting research samples or interviewing farmers. So there's a lot of, in addition to that, obviously there are lots of visits to the research stations and things. I think I've probably done over 50 trips to Africa in the last 15-20 years since I started working. So it's kind of become like my second home, to be honest. So this is just some of the pictures to give you an idea for kind of things that we encounter. So here is where my colleague is Andy. Is trying to collect some insects after for speaking to the farmers there. Farmers here, they're very happy to speak to you, and some of the most generous people actually you come across. The kids are a very common theme, so they're really so cheeky as well. So this is just an example of a house of a farmer where we interviewed him, and this is a house with a mud roof. He has built for himself, for example. So as I mentioned, kids are very common feature wherever you go. So they're always there and very happy to see you because, you know, they've probably seen the cars, some of them very rarely, some of them probably for the first time. So when they see the car, like when we kids in the village used to run behind the car, so they were doing the same. But when it comes to interacting with research collaborators, so this is the kind of work. So they take up the experiments. We go there and monitor and collect samples and do some of the very high-end molecular research. Like I said, yeah, it's another field trial that's being taken in Tanzania here. And more often than not, I am seeing in situations like this where fixing the equipment, these are the equipment that are shipped from the UK. Basically, we commission a molecular laboratory from the scratch, from the beginning, and go and install and train students and staff to be able to use these facilities and able to do their own work in their own laboratories. So that's the whole concept. But all the while, I didn't really go into the technical details of the lot of experiments because this probably is a very diverse group of audience. So I think this would be probably too much to go into the technical details. So that's why I'm just giving you an overview. But all the while, all this work or research or experiments that we do, whether in Africa or in the glass houses or in the molecular labs in the UK, is keeping in mind controlling the disease, or in other words, how we can increase the food security. How can we help farmer to grow better and more food? And especially for controlling the disease, cassava brown stick disease, these are the three approaches we took. Developing resistant varieties, which is obviously the most beneficial way to do it. As I mentioned, using pesticides is really not an option in Africa. And then phytosanitation, many of you may have heard that phytosanitation means using clean seed material as well as removing any infected plants, as well as controlling whiteflies which transmit the virus. Okay, so I did want to mention some of the examples of work that we normally do in the UK is really use cutting edge research technology that's available in Europe, such as next generation sequencing or RNA-seq, in this case transcriptome analysis, to identify basically genes. This is basically means gene mining, to see which genes are responding to virus infection in cassava plants. Here is on the left-hand side, you see a picture with the 19 genes that are common to these resistant varieties. Among all the 4 resistant varieties, there are 19 genes that are uniquely upregulated upon virus infection. Okay, so there are a lot more upregulated among susceptible and tolerant varieties, but that's a different mechanism of disease resistance. But we wanted to focus on these 19 genes and see what they are. And not surprisingly, some of them are already previously known described genes in other plants. And to further confirm their role, we are basically knocking down some of those genes. Effectively, this is a transient GM expression of the genes to make the gene less effective, so we can inoculate the virus to see if the resistant variety can become susceptible. Okay, so just kind of give you a flavor of the work that we were doing in the UK. So this is obviously complemented with the field research in Africa, including the breeding, so that's really the crux of that, developing resistant varieties. I will tell you which are all the varieties that have actually gone through the pipeline a little bit later on in the impact section. Then looking at the phytosanitation, so basically this involved curing cassava from virus infection using some of the advanced tissue culture, chemothermotherapy techniques, as well as virus indexing protocols. So in there, what we did was we collected about 35 cassava varieties from different 5 most affected countries: Tanzania, Kenya, Malawi, Mozambique, and Uganda. And we brought them to the UK, and we grew them and took them through various treatments for eliminating the virus. and then ship them back to African laboratories or partners. So these are our project partners. They are actually rescuing the tissue culture cassava sent from UK originally, and from the UK, and then they grow them in the fields. And if you're wondering why it cannot be done in Africa, I'm afraid, like I said, some of the molecular tests are still difficult to operate in African conditions, largely because maybe so still the capacity is not there. There are not enough trained people, or if they have enough people, then there is an issue of lack of power, for example, or lack of resources, molecular reagents. They're not easy to acquire, so it kind of delay the entire program. So that's why sometimes we get the material to the UK and then help progress faster. So here are just some of the examples of where cassava varieties that were sent back to the countries they were growing, and our partners are happy because the cassava is the disease-free cassava. Without the disease grows much better, and you can see here where it's grown really twice as tall as me. Normally diseased cassava is stunted and doesn't grow very well. Just to give you a very vast, really a large amount of work that's taken up in this project called 5CP. The red dots, if you can see on this map, is where we took the field trials all the way from Eastern Central Africa to the Southern Africa. So this is a really a massive amount of work we did for identifying the varieties that are suitable for this each region. So it's a really great undertaking, like I said, in the 5CP project, in which I was a partner, and where the varieties are now, some of them are identified and to be suitable and released as varieties in those countries. Kind of final control option is whitefly. If you can control the whiteflies, of course, you can control the spread of the virus. This is an ongoing work funded by the Bill and Melinda Gates Foundation, where this graph shows at the x-axis the various cassava varieties and the number of whitefly nymphs on them. You can see some of them are obviously highly susceptible. They're supporting more nymphs, whereas on the right-hand side of the graph, there's some of them are supporting very fewer nymphs. Again, this was going to say that we are using a very high cutting edge molecular research to understand what are all the genes that might be contributing to this resistance, again, to the intention of developing molecular markers for use in breeding programs. This picture I overlaid is kind of really is a take-home message in terms of the resistance we are finding for whiteflies. These are the white dots are actually the nymphs of the South American whitefly. You can see when we're given the equal number of whiteflies for different varieties, some varieties are highly susceptible, develop this many number of nymphs, while some others are highly tolerant and they really suppress whitefly multiplication. So we are really working with some very good material, and we're going to make a much more impact as we start controlling not just the disease, but also the whitefly. And some of you might be wondering, what about the transgenic cassava? You're talking about using some cutting edge technologies in Europe, and as any work has been done on that. Yes, indeed. We also developed some transgenic cassava, not just the team that I'm involved, but also other research groups, and in which two technologies like RNA interference, and CRISPR-Cas9 technologies have been used. However, I didn't put this as one of the control option because acceptability, as many of you know, around the world of GM crops is still a major problem. There's been a lot of ignorance, and in my view, it's basically a blind following the blind mentality has been developed around the world, and I'm ashamed to say more so in Europe. In some of the most educated and advanced societies really vehemently oppose GM technology, although it's being adopted all around the world, more countries than let's say 10 years ago. But something I actually wanted to put into context here, many people, I don't know if you're aware, most of the vaccines produced actually involves one or the other form of GM technology. This is the bottom line. So we are very happy to have injected the GM vaccine into our bloodstreams, but we are not happy to kind of accept GM crops. If instead we are happy to dump thousands of tons of weedicide or insecticides to control pests, but not happy to eat it. So this is I was in another webinar yesterday, and where I was horrified to note that in India, for example, it's the same. It's just not the common people, I mean to say. It's even those who are sitting on the committees who are controlling this approving GM events. They're happy to approve the GM vaccine, for example, but they're very kind of adamant to make the GM crops and not to reach farmers. So there's really is no kind of scientific or common sense involved in my view. So I hope really that this will change, and where we can begin to see, especially, where it has a very clear societal benefits. I think, GM should be allowed, but it's not for me to say, obviously. And one of the other things that I'm really passionate about is not just doing research, but improve the capacity of the farmers, because there's no point in you just keep doing the work and keep your partners where they are to the field research, which is really not a way to go. So this is the kind of examples where you have a big, beautiful laboratories built, but they're quite often empty. So there is no equipment there. So what I do really is right at the beginning of writing the projects, you build in improving their capacity. So you buy all the equipment, you basically plan what a molecular lab might need in Africa, you plan for it, you ship all the equipment. There is a lot of process involved, customs clearance, tax, this and that. But with all that hurdle, it's clearing the hurdle, you ship the equipment, and then you go there and you open up and you train your partners, and so basically set up a functional laboratories. So I'm pleased to say that I've been able to do that in at least 3 countries, Nigeria, Tanzania, and Malawi, during my projects. Okay, this is moving away from pests and diseases. I mentioned how it is easier to look at other concurrently occurring problems. When you're in the field, this is what you see. So maize is being severely hit by drought in many countries in Africa. I think if you remember the table, maize is the most important food for the world, and in fact, it's true even for Africa. So when farmers are hit like this, their crops, so effectively they lose everything. There is no food. There are Kenyan names. If you actually do a Google search, there are some names linked to like these seasons or events. Wanjala apparently means is someone born during extreme food shortages or during drought. So it's really kind of that bad, I mean to say. So when I was actually being in the field, so I thought, oh, okay, so we have one of the most diverse, most suitable crop for maize, so rather during drought conditions. So why don't we promote cassava in areas which are predominantly grown, maize is grown. So in other words, was trying to diversify crop rather than monoculturing and depending just on maize. So if we introduce cassava and encourage farmers to grow cassava and connect them to the market, this is the important thing. Not just encourage them to grow cassava, but also you need to train them. And then if they have lots of cassava produced, you also need to link them to the market. So they will not be complaining about shortage of market. So which is basically the concept that we developed and introduced. Basically, all these cassava sticks from predominantly cassava growing areas were procured in projects that I lead, which is currently funded by African Union that I lead at the moment. And these sticks were distributed around the country where maize was the monocrop. So in this way, we really help farmers to diversify their food production. So when there is a massive drought or disease, obviously, we try to minimize that impact on their livelihoods. So if you're wondering, I mean, obviously, money is important. None of the work would be possible without this. So I've been really lucky to be part of many big projects, being able to win some of the grants myself. So it obviously means it's a lot of collaborative work, as I said. So many people actually have contributed to some of this work. So kind of conclusions in terms of the impact that has created my work. The cassava varieties that we have cleaned and developed have been grown in 7 countries at the moment, which is really an amazing expansion. And that was the first major work in the regional exploitation of the cassava varieties. Basically, regional approach to tackling a disease problem, because if you just addressing one problem, in the neighboring country, the problem will be there. So that we are very pleased to be able to do that. And there are lots of other projects that were using our cassava varieties. The reason being, it's not easy to get rid of the virus once the plants are infected with the virus. I think many of you probably know the famous proverb in virology is, if the plant is infected, pull it and burn it. Okay, so to rescue that germplasm and to be able to give them back to the African partners was a really massive success. And so because of that, the many other projects which are funded by various donors really, make use of that, the facilities, basically the varieties available for using even more advanced technologies that you and I can be able to do, something like GWAS. I think maybe some of you might have heard about genome-wide association studies, or using very high cutting-edge molecular research. Just to focus on the kind of impact these varieties created in one country, in Tanzania, for example, over 3.6 million pre-basic cassava seed was produced in one of the projects, 5C project I mentioned. And we set up something called a seed system, which was non-existent for cassava. Seed system basically means where you basically outline all the protocols and the ways how one can produce a healthy cassava seed. And if they follow that protocol, then they'll be able to sell this seed to other farmers. Okay, so that kind of protocol was not there. So we developed that protocol in the project, and we were able to actually change a seed act in Tanzania Seed Act in 2017. So it's really a major policy change. So people can actually start growing cassava and start selling them. So it's become like a business. Here, about 800 cassava seed producers are currently growing this cassava, healthy cassava seeds, and selling to about 29,000 farmers in 2018-19. So we think that this is going to become a really big multiplication effect, where the healthy seed will be bought, and the farmers who bought it, if they follow the guidelines provided, there is obviously a seed certification agency that follows all those protocols, making sure that those who are producing the seed will be of good quality. So, but we are able to kind of start that process and contribute to it. So that's really a great progress. And basically, I think that's coming to the end of my talk. Linking back to the title of how studying and working in the UK really is, I don't think I kind of made any huge impact or anything hugely different than most other people. In the sense, basically, if someone with a bit of dedication and hard work and focus, anybody who is listening to this talk would be able to succeed in the UK or any kind of environment for that matter. So before closing, so basically, as I mentioned, this is a huge collaborative effort and funded by major donor of my work is Bill and Melinda Gates Foundation. So I think that's it. I would end there. Thank you very much for listening. If you have any questions, whether it's, like I said, whether it's on general studying or getting a job in the UK or on research, I'm happy to take.
Yes, sir. Thank you so much. It's so inspiring to listen to you, and it's great work that's going on, sir. Thank you for throwing light on so many aspects of cassava production, as well as how it is one of the most important crops to fight world hunger. And I would like to congratulate you for being, it's like a rags to riches story. So we're so inspired by you. I'm sure a lot of youngsters on this webinar would be looking forward to a career like yours. But I would say hard work goes into it, and you've been very modest about your achievements. Yeah.
Oh, thank you very much. Yeah, I wanted to apologize. I didn't share too much of the experimental or technical details because of the very vast nature of the audience. So,
but they can always get in touch with you if they're interested in your research work. Okay.
That's
so
right,
I have a few questions from the participants. There's Mr. Sharan Mullur, he says, sir, I'm from Tanzania. So after studying in UK and working there, that's you, what motivates you to take up research in African geography?
Okay, right. Yeah, no, that's a very good question, Sharon. I know Sharon. Hi, Sharon. Okay. Yeah. Well, I think initially it was, to be honest, where you can make the, where you have the opportunity effectively and where you can make the maximum impact. So opportunity in terms of winning the projects. So if there is a kind of big problem happening in Africa, for example, so that's where you have more likely to succeed in getting the grants. So in a way, it's like a selfish motive in a way. So because, like I mentioned, you need to have projects to keep you a job in a way. But early on, I realized that Africa is where most of the problems are there, mainly because of the maybe the challenges in those countries. The infrastructure is still to be developed, and the capacity of research still need to be improved. So I think it probably went like that. For example, in India, if you compare it, so we have a fantastic capacity. Our research infrastructure very well developed, and our extension and universities and the ICR systems are very well developed. So they probably won't be looking for help from the UK. So it's kind of identifying the opportunities and then going with that.
Okay. Shankarappa KS wants to know, what are the genes which are resistant associated with whitefly resistance, and what is the mechanism for whitefly resistance? Yeah.
Okay. Yeah. Hi, Shankarappa. Yeah, I know Shankarappa. There are two mechanisms of resistance for whiteflies. One is antibiosis and antixenosis. I mean, getting into very technical options. Antibiosis is when the whiteflies start developing on the plants, they basically will be affected. For example, nymphal development, when the nymphs, whitefly nymphs start feeding on the plant, so it will, they will not develop into adults. So it's antibiosis. Antixenosis is more like a repellence. So whitefly plants have phytochemicals and volatiles that will repel from feeding on them. So these are kind of two basic mechanisms. The detailed molecular mechanisms of resistance is kind of really, we are just exploring. Some of the very early data are coming up, and quite surprisingly, they are quite similar to, at least in cassava, some of the chemicals we are identifying are similar to those that are also responding to virus resistance. So maybe there is a basal resistance mechanism for both whiteflies and virus disease. In other words, biotrophs. So that's what seems to be happening. So look out for our papers. They are really coming up in a couple of probably months or so. Yeah.
Okay. He also wants to know, does the Seed Act include national certification program for cassava?
Absolutely, yeah. So without the national participation of national bodies, it will not go anywhere. So a project alone will not be able to sustain it because you have only 3-4 years duration of the project. So it is the national bodies who will be able to take it forward. So the Tanzania, as task is called, Tanzania Seed Official Certification Agency is very much involved, and they are the ones who are kind of really driving it forward once the project ended.
Right. Both Shankarappa and Sanjana Vishwanath want to know what are the fellowships for masters and PhD programs, if you have any information on that.
Okay, yeah, for masters, there is something called Commonwealth Scholarship Program, Shared Scholarship Program is also called, SSS. So that's actually open for Commonwealth countries like India, not for all the countries. So people can actually look for shared Commonwealth scholarship scheme and search and actually go through that. The ladies are especially preferred. They want to, increase the gender imbalance that has taken place so far in science. So if you're a woman candidate and looking for a master's program, yeah, please look it up on their website, and all the information is provided. One can go through that. And PhDs are more generic in the sense you basically need to look for PhD positions advertised by various universities. There are some websites. It's called, one of the common one is called www.jobs.ac.uk. So there they advertise, most PhDs advertised in the UK. And depending on your interest and subject area, basically when they are advertised, you need to basically apply for those positions. There'll be details given. Many of them might be only for European students. You need to be careful of that. They're actually open for international students. So that is the main way to get into a PhD. Actually remember that whether it's actually master's or PhD, you must have done the IELTS, English language test, to be. You can apply actually if you have not done it, but if you have done it, you will be in a much better position than those who has not done the exam, because I sit in many selection panels of students, and so we always give preference. We try and give preference to the IELTS, because many students who might be qualified, but if they fail in IELTS, so that becomes a big drag for those who are recruiting the students.
Okay. Mr. Raju wants to know, have you developed the cassava varieties that are resistant to virus? Is it done, or it's a process is still going on? And he also wants to know what is the average temperature of African countries during the crop period?
Okay. Hello, sir, Raju. Yeah, yeah, I know Raju. Yeah, the varieties have been developed. This is like, breeding is a very continuous process. It takes at least 10 years to develop a vegetatively propagated crop like cassava, which is also actually, I didn't mention that it's a 1 year crop cycle. From seed to set, it takes at least 1 year, unlike other cereals. You can have seed to seed in 3-4 months. So it's a very slow process. So many of the varieties were actually been in the pipeline much before some of my projects were involved. So we kind of basically help harness all that work that has been developed. So we have varieties that are highly resistant, in fact, actually immune varieties that have been identified by, not by actually ourselves, but a group in Germany. So that's very rare to see for a virus actually to have immune varieties. So these varieties actually come from South America, where the cassava originally comes from, Amazonian basin. So naturally, there are some resistance available there. So they're being tested, like I said, in Germany, and they're being now used in many breeding programs in Africa, not just conventional breeding. I mentioned the GWAS, for example. Other projects are working on it. So one thing I forgot to mention is that Bill and Melinda Gates Foundation have really supporting cassava research in a massive way. So they're literally putting hundreds of millions of dollars on this crop, basically to help support the food farmers to grow better food, better cassava varieties. So they approach all possible ways to try and make a rapid progress. So yes, sir, yeah, the resistant varieties are available. But resistant means, I think many plant pathology students will know that they can still infect by the virus. So, but they may be suppressing the virus, they can be infected. Okay, so now we are talking about some immune varieties. So immune varieties and transferring that resistance probably will take another, as I said, quite a long time, 5-6 years before they can be available for farmers. And in the meantime, GM varieties are available if we have any luck with the politicians. So we might actually even have GM resistant cassava varieties. Yeah.
Nagraj Naik wants to know the bacteria used for whitefly control.
Oh, okay, right. Yeah, very good question. That is actually a beautiful piece of work that I'm sorry I didn't have time to describe. This is really some of the fascinating. The science is what excites me, to be honest. So there are in mosquitoes, there's something called Wolbachia was identified to have a negative impact on the insects, basically on the mosquitoes. So this is a bacteria, just to give a kind of make it clearer to all the listeners. This is a bacteria that lives inside the insects, and there are actually a whole bunch of bacteria. They're called endosymbionts, and some of them actually are very beneficial to insects, and some of them are harmful. So what we are trying to do here is really identify the most harmful bacteria, whether it's for suppressing virus transmission or whether it's actually suppressing the biology of insects, and then basically try to multiply them and use to control the insects. So it's good that question was raised. Actually, I was one of the 10 NRIs, non-residential Indians, who won a very competitive grant by the Bill and Melinda Gates Foundation on that specific topic on Wolbachia. So yeah, so that is being used, but this is like, blue skies type work. It will take a little bit of time to work out all the various the research elements of the technology before we'll be able to use it. But it's being used actually on mosquitoes to control dengue and chikungunya virus. So there is a huge potential that we can exploit that for agricultural pests, not just for whiteflies, for others. That'd be an amazing, awesome technology.
And yes, okay. So Raju also wants to know whether this is a seed-borne disease. If not, then what stage of the plant gets infected by the virus?
Yeah, good question, sir. Actually, in cassava, the seed means stem cuttings. I think this is one clarification. So the true seeds are not infected. So when we do the crossing and develop the seeds, the virus is not transmitted. So which is extremely good news. This is how actually in the past the cassava germplasm was exchanged between the countries, except in the project that I described, where we are able to exchange the vegetatively propagated material. So in the stem cuttings, obviously when the plant is infected, when the farmers use the same stem for propagation for the next crop, the virus is transmitted basically to the next field. So farmers are really by far the #1 spreaders of the disease. So there is quite a lot of education issues there. Farmers not necessarily aware of what causes the disease, how it spreads, and how we can control. So that's also part of the process. We kind of need to educate the African farmers. But whiteflies also naturally spread, so from healthy to diseased plants. So it gets basically by two means, either by stem cutting spreading by the farmers or by the natural vector insect when the crop is very young. When the crop is old, the virus infection becomes harder.
Okay. So next question is from Sanjana. Sanjana is already doing her MSc in biotechnology in the UK in Newcastle. So she wants to know what is the opportunity for internship and jobs because of the COVID-19 situation.
Okay, right. Yeah, I think I must say it's really a bit tough at the moment, especially internship. It's probably non-existent. I'm sorry, Sanjana, because even ourselves, we are trying to partially open up the labs for our own PhD students, and we have very strict regulations of one person, one room policy, and we have to put in a rota system, who is coming in and what time, and it's really, really very strictly monitored because I think many of you know that employees will have a duty of care for the people who are working. So if employers don't take enough precaution, then anybody gets sick, they can really go and sue the employer. That's it's a big issue in Europe. So internship, I think, unless you already have established a connection with your research team, that you want to work on something, then it's very difficult to develop a new kind of identify a new lab who are ready to. Yeah, it's too much. I think we are trying to fit in the existing students who are all our PhD students. A lot of our PhD students are suffered really badly because they couldn't go to the lab, and so trying to find an intern is going to be hard. Yeah.
Sorry about that, Sanjana.
Mhm.
But I hope the COVID-19 situation gets solved and everybody is up and about. We're all waiting
Yeah,
to do
yeah,
that everywhere. Yeah.
yeah, indeed.
Mr. Narasaraju from US Bangalore wants to know the common domain and resistance gene of cassava mosaic,
Hmm.
and do they have common domain as like other resistant genes? And is there any IPM practices that they follow for the management?
Okay, yeah, no, hello, sir, Nagaraj. Yeah, nice to hear this your question. Basically, again, this is some of the work that we did. Oh, this is going to be a long story. I'm not going to take too much time.
Don't worry about that.
Basically, there is a massive breeding program took place in the 1930s and 40s by the British colonial scientists. So when East Africa was under British rule, so they carried out some of the most extravagant crossing program. So what happened was they used this tree cassava, what we call tree cassava, which was highly resistant to the disease, and crossed with the cultivated cassava to transfer the resistance genes. Now, what happens when you do, such wild cassava with cultivated cassava? You also have a lot of unwanted the drag, basically. So there was a lot of back dresses were done to get rid of the unwanted agronomic triers and but retaining the resistance from the tree cassava. So one beautiful thing is we were able to actually collect those materials that was actually, bred in the 1930s and 40s, and we are able to use our RNA-seq technology to map exactly which part of the genome comes from the tree cassava and which part actually is carrying the resistance. So it's really, really fascinating work. I mean, especially really linking it back to all the way to such a older breeding program. So we definitely know. And some of the resistance genes that we are identifying are have NBS-LLR domains, and some transcription factors are there, and we have uh, the most prominent one, I'm trying to remember, phenylpropanide pathway, actually, PAL1 gene. Actually, one of the students from India, CG Kavil, she did herself and her husband did a PhD with me. They actually just about finished the PhD. So she identified PAL1 gene as contributing to resistance. So we definitely have a lot of cues, candidate genes. And in fact, one slide where I mentioned about gene knockdown was her work, where she knocked down the PAL1 gene and shown that the resistant variety becomes susceptible. And what does it actually mean? That that gene is really, really important in terms of giving resistance to that variety. So yeah, we have quite a advanced data set on that, sir. Mm.
So that's the importance of documentation and research. You can really go back to so many years and get some ideas from there.
Yeah. I mean, British, yeah? So they really write down every little detail. So that's right.
Mr. Nagaraj UB says that he has heard that some small viruses affect giant viruses. Is it possible to use this mechanism here?
Small viruses affecting giant viruses. There is always, it's probably like in the ecosystem where many things, different organisms interact. So it is possible, although I must be honest that I haven't really kind of come across myself the literature on that. But it's very common that many interactions take place between various organisms. I mean, you think about the smallest organism like bacteria is really can be controlled by these viruses, a group of viruses. So they're actually being used also as therapeutics as well, you know. So yeah, so even one thing that we are actually finding out from the all this next generation sequencing technology is that what I think even humans, what do they say? Like about is it 20% of us is not actually human cells? It's all various other organisms, bacteria and things which are actually living inside us, and they do all kinds of things. So there is a lot of interaction takes place. So it is theoretically possible. And in terms of yeah, practicality, there are many such interactions between fungi, bacteria, and even viruses. I think one of the famous examples I can recall is in the Yellowstone National Park in the US. Some grass was able to grow under extremely high temperature water fountains at 60, 65-degree water temperatures because there is a fungi and the virus are really have developed a symbiotic relationship with the grass to be able to give that kind of resistance phenotype for that grass. So yeah, it's definitely possible, but I'm sorry, I don't know any specific example on top of my head.
Okay. Mr. Nagaraju also wants to know if there's any work on induced resistance.
Induced resistance is just actually coming up in cassava. There is actually, incidentally, there is like a fungicide that was accidentally found to be inducing resistance for whiteflies, as well as inducing growth. You know, vigor of the plant is really, you know, growing very well. This is the work actually by Brazilian team, and they're working together with the Syngenta Foundation, not Syngenta company, Syngenta Foundation. In fact, this is currently being promoted in the UK to go with the seed system. I mentioned about seed system where, you know, people are, some entrepreneurs, you know, smart farmers growing cassava and complying with all the regulations. And now we are trying to see if we can, this use of this fungicide can be adapted at this entrepreneur farmer levels, where instead of selling the seed as it is, if we treat these seeds with fungicide, so they actually have a double advantage of them being protected, and also vigor is enhanced as well. So yeah, some of this has been happening, but not perhaps like maybe in the sense of what Professor Nagaraj is thinking about, the application of chemicals later on. Yeah, in fact, actually, we are doing a little bit of work with Dr. Vasanta Kumar Timkapura. I think he's growing cassava in his backyard, and with cassava mosaic disease, I've seen his picture where treated plants are really growing, looking tall compared to the infected plants. So he probably has the very latest information on how they are doing. And unfortunately, I know he couldn't join his in another meeting.
Okay. So our last question for today is Mr. Hanumantappa Shivkumar wants to know if you could throw some light on fall army worm in corn.
Okay, yeah, I think that's Shivu from Bhumika Troop, probably. Yeah, hi Shivu, if you are from there. Yeah, I'm not really kind of familiar with fall armyworm myself, but just the general information I gathered is, yeah, it's a really big problem, massive problem. It's spread around the world. Yeah, it reached India as well. I mean, China is also experiencing. So this is actually one of the major problems that farmers have to deal with. I mean, at the moment, I don't think we have a solution to this. Some people are recommending controlling by traps, but I don't think it's really working to that. And many like indigenous technologies of applying mud and other various like clay material to the infected parts, and spraying is obviously taking place. But especially in the African context, spraying doesn't work basically. So this is why we look for other options. So no, I'm afraid really apart from this general information knowledge, we probably have on Falamium, I don't really kind of know anything. Maybe like I could say that institutions like CIMIT, they work exclusively, on maize and wheat and other like cereals. So I think if you look it up on their website, I'm sure you'll be able to find lots of information on the maize germplasm. And one thing for sure, there's a huge amount of work is going on for controlling fall armyworm.
Okay, so thank you so much for taking time off to address our audience. I thank you from Phoenix Academy and on behalf of all the participants. We've had a very good turnout. Thanks to all the participants for joining us. The link to get your e-certificates is given in the chat box. Please click once you fill the form, the feedback form, you will receive your certificates in your inbox. And thanks to all the Zoom attendees. But last but not the least, I like to thank my team at Phoenix Academy for putting up this webinar. Please follow our page, Phoenix Academy Mysore, on Facebook for updates of the coming webinars. You can also write to us at ourphoenixacademy@gmail.com. We'd love to hear from you. And I'm very happy to announce that we will be releasing our website tomorrow evening. So stay tuned, and all the details, the URL will be shared on our Facebook page. So follow our website for a lot of exciting things in agriculture and agribusiness coming up. Thank you so much. This is Dr. Chaitra signing off.